Hey, welcome back, AP Calculus students. Today we're looking at 6.3 definite integrals and antiderivatives. So we're focusing on these rules here. I know they're a little bit out of focus, but we'll just kind of talk about what each of these mean. So the first one is the zero. So notice that for the first one, the start and the end are the same. So if the start of the integral and the end of the integral are the same, there's going to be zero area under the curve. So if start and end are the same, then it's going to be equal to 0. Okay, the additive property just says if you're going from A to B, and then we're adding from B to C, then that's the same thing as just going from A to C. Alright, number 3, order of integration. So what this says is if we flip-flop the end and the start, so instead of starting at A and going to B, if we go from B to A, then all that happens is negative. So if we switch, start and end, just the whole thing becomes a negative, or the opposite of. Okay, part 4, constant multiples. We know that from our derivatives that we don't have to include the multiples. We can do our antiderivatives or our integrals by taking out our constants. Okay, and then the number 5, sum and difference, is if we have the integral of two things added or subtracted, it's the same thing as them separately. And then the last two are not quite as important, so we're just going to kind of skip over those. Alright, so let's see how this applies. So for this example, it's saying suppose that we have these three different integrals, right? From -1 to 1 of f of x dx equals 5, from 1 to 4 of f of x dx equals -2, and from -1 to 1 of h of x dx equals 7. So notice that the first two are f's, the second one is h. And yeah, let's kind of talk this over. So for number 1, we have the integral from 4 to 1 of f of x dx. Now look over here, we don't have on the top anything that's going from 4 to 1, but what we have is the one that goes from 1 to 4. So we said from the property, where is it? This order of integration, right? If we switch the end and the start, then it's just the negative of what we have. So this one would be the opposite, or the negative of -2, which is 2. Okay, so for number 2, it's asking us to find the integral from -1 to 4 of f of x. So the key here is that these both got to be f of x, and then it's got to go from -1 to 1, and then from that point 1 back to 4. So notice that there's no gap, right? It goes from -1 technically all the way to 4 if we add them up. So that's going to be using this one. The number 5. Right, so we can just take that as one whole thing. So if we add them up, we get 5 plus -2, which is 3. Okay, for number 3, this is saying that we're doing the integral of -1 to 1 for 2 f of x and 3 h of x. So in this one, because we have the h of x from -1 to 1 and the f of x from -1 to 1, we can just take those separately. And notice that these 2 and these 3s, they're just multiplying by whatever we get. So the f of x from -1 to 1 is 5, so 2 times 5. And then the h of x from -1 to 1 is 7, so we're going to do 3 times 7. It's going to be 10 plus 21, which is 31. Okay, so for number 4, we're going from 1 to 0 of f of x. So notice that there's no zeros in here, right, for our two f of x's, these two f of x's. Right, and we can't subtract it or do anything in any way to make it 0. So what we're going to do is say that this one, not enough information. Okay, and then number 5, be careful for this one too, because you think that, all right, because we have -1 to 1 that we can just multiply by 2 to get to -2 to 2, but that's not true. We have to have the exact same integral. So this one is also not enough information. And as well as number 6, because we do know what f of x is from -1 to 4, right? Because we found that earlier. Where is it? That's 3. But we don't know anything about h of x. All we know about h of x is from -1 to 1, right? We can't combine h's with f's and say that's the same integral. Okay, so this is also not enough information. Okay, this one is not too bad. So it's saying if f is the integral is integrable on AB, then its average is 1 over b minus a times the integral a to b f of x dx. So this is the integral part, and then this is how we find the average, right? So a is start, b is the end. So we're just technically dividing our integral by the change in x, or the change in x. Okay, so it says find the average value of f of x equals 4 minus x squared on 0, 3. Does f actually take on this value? All right, so let's do this integral first. From a to b of f of x dx. And what that's going to be is, well, it says we're starting at 0, we're ending at 3, and our function is 4 minus x squared dx. So let's go ahead and use fn int on our calculators to do that. So remember, you're just going to do math 9 to get to your integral. And go ahead and punch that stuff in. And when we do that, we see that this is going to be equal to 3. So this whole thing right here, the integral is 3. Now we just have to find the average. So 1 over 3 minus 0, right? Because this is the start, 0. This is the end, 3. So 1/3 times 3, this whole thing is going to be 1. All right, so the follow-up to this question is asking us, does f actually take on this value? Now, this comes back to the mean value theorem. Now, mean value theorem for derivatives was that if we can find the average value, the mean value of our function, then we can definitely, then at some point on our function, then we must have also the same tangent. All right, so the mean value theorem also applies to integrals. So if our value is 3, if our average value is 3, then there must be some point where f of x equals 3. All right, and that's true. If we look at this part, we know that if we plug in a 1, right, because 1 is on our interval between 0 and 3, 1 is definitely between 0 and 3. If we plug a 1 in there, then we get 4 minus 1, which is 3. Okay, so this is a pretty short lesson today. Hopefully it gives you guys some time to think about all the stuff we've done up to this point. And yeah, hopefully your work is also easy as well. Okay, good job.